Hi, welcome to this session. In this session, we will discuss about the successive replacements as you can see on the screen. So successive replacement is particular case in which some quantity of the mixture is replaced and that happens repetitively. So to explain what kind of question we are discussing, I'll quickly take an example and here I've kept everything in variables and we would like to discuss that how to answer such question. So now we have a question here, a milk water solution that has p liters of pure milk. If x liters of mixture where x is less than p is replaced by water and this process is repeated n times, after which solution has q liters of milk left, then find the ratio of milk left to the original quantity of milk in the solution. So, before I tell you any formula, let's quickly understand how to derive that formula and let's understand the process because the process is really important because in GMAT you don't get too many steps but still you need to understand the process even if you have to execute one or two steps of this particular explanation. Now, we are starting with first basic understanding that suppose we have the solution here and it is filled till this place and there we have some solution which has some quantity and let's assume that it has quantity because it's not given, so I'm saying that the quantity is 100. Now that's the total quantity and here we have some solution milk and some have water. So question says that there is p liters of milk in the entire solution. Now what happens after the first replacement? That's the first step we need to understand. So the first replacement means that we are taking out x liters of this mixture and we are replacing it with water. But if you take out x liters, understand one thing that any solution that we talk about is considered a homogeneous solution. Homogeneous solution means that in every part of it, the percentage of the milk will remain constant. So if I have 100 liters of milk solution which has 80% milk, then if I pick 1 liter, that 1 liter will also have 80% milk. If I pick 5 liters, that will also have 80% milk. So the percentage remains the same, right? So if I'm picking out x liters of this solution, then x liters would have some milk and some water. Let's quickly find out the quantity of the milk because that's what we are basing our calculations on. The milk in this x liters will be equal to p% of, because the total quantity is 100 liters and we are saying that p liters is milk in it. So the quantity of milk in x liters will be p% of x. Now every time we are going to make an equation and that is on the milk left after such replacements have been performed. So after the first iteration, the milk left will be, we had p liters originally and now p% of x has been taken away and that has been replaced by water. So the milk left will be this much, which can be written as p multiplied by 1 minus x over 100. So that was the first step. Now we are proceeding to the next step. That means now we are going to discuss what happens after the second replacement. Now after the second replacement, we still have the total quantity of the solution as 100 liters, but now the milk left in this 100 liters is not p liters, it's instead this much. So because it's a complicated expression, so let me just simply assume it to be y. So what I'm saying is that 100 liters now has milk in it which is equal to y% or y liters. Now once again I am doing the same replacement, that means I am taking out x liters of this new mixture and then replacing it with water. So now the new x that I will take out will also have the same percentage of milk in the x liters. That means now I will have y% of x liters, the quantity of milk in this x liters. So I'm once again going to calculate what is the quantity of the milk left in the solution and that will be, I originally had y liters after the first iteration and now this much milk has further decreased because if this x liter is taken out and replaced with water, this much milk does not come back. So I am feeling now the net subtraction, net reduction of the quantity of milk equivalent to y% of x. So now the milk left can be represented as y taken common 1 minus x over 100. Now I am going to replace the value of y here. So it becomes p times 1 minus x over 100 times 1 minus x over 100. So I'm writing it 1 minus x over 100 square. So that is what happens after the second replacement. Now let's quickly see what happens after the third replacement. Now after the third replacement, we still have 100 liters because the quantity that we are taken out has been replaced by water. That means the net quantity of the mixture does not change, it remains to be 100, but the percentage of milk is continuously decreasing because we are taking out the milk mixture and replacing it with water. Now, after the second replacement, we had this much milk left. Let's assume this is equal to Z liters. That means out of 100 liters, we have Z liters milk in it. Now we are once again performing the same iteration, and then we are taking out X liters from it. So the milk that goes out with the X liters that we take away from this mixture is equal to Z percentage of X, right? Because the X liters will now have Z percentage milk. Now after the third iteration, we see that the milk left will be equal to, earlier we had Z, and now Z is being subtracted by Z percentage of X. So what we are left with is Z taken common, 1 minus X over 100. Now we are replacing the value of Z from the second replacement case, and now we get P times 1 minus X over 100 to the power 3. Now this is where we need to understand that there is one pattern that we can see, that the milk left is always equal to this much, and the exponent of 1 minus X over 100 is continuously rising as the number of replacements are increasing. So looking at these three steps, we can generalize one principle, that the milk left upon original quantity of milk, because now I am taking this P on the left hand side. So original quantity of milk, and this is the case after n iterations, because now we have seen 3 iterations, after n replacements, will be equal to 1 minus X over 100 to the power n. And this is how we generalize this principle of successive replacements, multiple replacements. So any question that requires these many replacements can be answered using it. Now that we have understood this concept, I would like to take you to one of the questions, and we will quickly answer that question using this principle. So now I'm quickly changing the board here. So we have, now this is a question that we want to discuss. All right. So 100 liters of mixture now that we have here, and the question says that there is 81% milk in it. Let me quickly write down the property that we left, that after n replacements, the quantity of milk left divided by the original quantity of milk will be equal to 1 minus replaced quantity over 100 to the power n. So this is the expression that we had derived, and I am going to use the same expression to answer this question here now. 100 liters of mixture had 81% milk in it. That means the original quantity of milk is equal to 81. Now 1/3 of the mixture is removed. That means the replaced quantity is equal to 1 over 3, or we can say 33.33% is replaced with an equal quantity of water, and this process is repeated several times till the milk concentration comes down to 16%. Now milk left is equal to 16 liters. Let's quickly understand. The question is how many iterations are needed. So we just have to simply substitute all these values in this relationship. The milk left is 16, original quantity of milk is 81, is equal to 1 minus replaced quantity is 100 over 3, 1/3 of the total quantity, divided by 100 to the power n. Right? This is 33.33% of 100 only, so that becomes 100 by 3. So now let's quickly simplify this. So we have 16 over 81 is equal to 1 minus 1 over 3, because the 100 gets cancelled out, to the power n, which further gives us 16 over 81 is equal to 2 over 3 raised to the power n. But 16 over 81 can further be written as 2 over 3 whole to the power 4. because 2 to the power 4 is 16 and 3 to the power 4 is 81, and that is equal to 2 over 3 raised to the power n. And this comparison of the bases and the exponents tells us that the value of n has to be 4. That means after 4 iterations, the required condition will be obtained. So that's how we answer such questions. And this was just to extend an understanding of how the successive replacement happens. I hope you enjoyed the learning. Thank you so much.